Okay.
The next speaker is Dr. Francisca Bulnes from Mexico, and the title is Homotopies to diffeomorphisms in symplectic geometry to field theory. So,
Okay.
let's
Thank you.
hear. Doc. Thank you.
Thank you. Well, the principal goal of my research and this presentation is to obtain the commutative scheme of derived categories propitious in the field theory using from the Flower cohomology perspective and construct the many diffeomorphisms usable to obtain the principal diffeomorphism through the homotopy theory and construct the Fukaya category, where this Fukaya category is more important in this study because she manifold contains all correspondences in the states, energy states, for example, and another phenomena, quantum phenomena, for example. And this here this is the Fukaya manifold that want to obtain, and the tools and backgrounds that use in this construction and this obtaining of the scheme of derived categories will be number one, homotopy between the submanifolds, the Lagrangian submanifolds in the symplectic geometry context, the conjecture Fukaya, and the Flower homology and cohomology corresponding in each case, and for two categories of the path integrals. The path integrals will be in the context of the graped derived category, who is the Fukaya category, and from the deformation theory point of view will be the deformed derived category in this context. We start with the Lagrangian functional and corresponding action given by this interval. We know this Lagrangian involves a connection, the flat connection in the space. The flat connection is very knowledge for all, everyone in geometry, in differential geometry, and the corresponding tangent bundle of the trajectory space, obtaining this first diffeomorphism, where this diffeomorphism is defined in these corresponding neighborhoods, and establish the correspondence between the neighborhoods, where the neighborhoods are the in the Fukaya category, and arise the following questions. Which is this quantum imaging of the diffeomorphisms? Well, it is necessary to work around the topology and induce this topology to obtain the corresponding diffeomorphisms through of the homotopy, the corresponding homotopy created by some conjectures and some results obtained in the works on this area. Will be this also an image of the other diffeomorphisms under the same topology, or this need extended or induced? Yes, is necessary. The corresponding paths in the space M is the space-time, including the microscopic structure, and this space-time is modeled by the complex Riemannian manifold, including even singularities, where singularities are particles. These particles deforms the space-time, and from actions similar with the first action given by this. Now, in the context of the energy states. These states are points of the Hamiltonian manifold. This Hamiltonian manifold is the base space of the Fukaya category, which is we want to construct in this research. Where this operator is the ground operator. This operator is mine and published in these papers, and is a extending of the Lagrangian concept in the states points of the Hamiltonian manifold. And we use strongly the homotopy given by this diagram. This diagram is commutative diagram, and was obtained for the construct of the mathematical nanotechnology theory, published too in this book. We need a homotopic construction to obtain this diffeomorphism. This diffeomorphism is our goal, the principal goal of this research, and this diffeomorphism is a symplectomorphism. These diffeomorphisms derive from the spectrum applied on the points of the loop spaces to obtain the corresponding copy in the Hamiltonian manifold. In the Hamiltonian manifold, we will obtain the Fukaya derived category. And was mentioned, we need Flower cohomology facts. The first fact is like the construction of the Flower complexes. These complexes must be very special and possibly must have little modifications of these complexes. This modification given by the Abandondolo-Schwarz theorem, and use these complexes to define the Flower cohomology to these special submanifolds, Lagrangian submanifolds, where these Lagrangian submanifolds are corresponding to the corresponding tangent space, cotangent spaces, where C is the first copy of the Hamiltonian manifold in the movement context. That is to say, in the space-time without the energy. And then the conjectures is we need some conjectures to specific induce the topology, as was mentioned before, and obtain this quasi-isomorphism between the complexes to the correspondent between the Lagrangian submanifolds, where this space complexes is isomorphic to the loop spaces. The loop spaces is the path integrals, is the paths or trajectories, pieces between the points or the positions of the particles in the trajectories in the space-time. And is obtained the corresponding of the homomorphism space invariant under this model. This model is special contents of the complexes with the variations, with the little variations given by the Czech cohomology and the others. And the constructions of that given and proposed in this theorem by Abandondolo-Schwarz. And the second conjecture establish the way of the generates the category, the derivative category, which is the homotopic category, where is our Fukaya category. The elements of the category are the images of the spectrum of the loop spaces, because it's symplectomorphisms. This space in the category, the Fukaya category. Also, we need the background result of the homotopy category. This theorem was obtained to define this spectrum and characterized by the fields related by the diffeomorphisms, and considering the ramification of the field in the case in the connection to the operator, the ground operator mentioned before. We consider the operator mappings elements of the homotopy category, and consider the natural homomorphisms. The homomorphisms related with the flower homology and the flower homology in the cotangent bundle spaces. Obtaining this rapid derivative category, and this rapid derivative category is the Fukaya category. We need to define and finish our diffeomorphisms and obtain this corresponding using the flower homology over the loop spaces and obtain the Hamiltonian manifold. And then the result, the scheme resulted is this, where this scheme can be seen as a rectangular prism, where these vertices are the derivative categories, the corresponding derivative categories, and use the corresponding and the logic demonstration will be fundamented in the compositions of this H in each case. The first demonstration is to prove the all correspondences around the rectangular prism using this diagram using in the homotopy theory and the homotopy relations, and prove these correspondences are commutative. The commutative property is proved to these correspondences. For the other way, we need prove the lateral coverts of the scheme. And the first cover is signed by is marked by this number in 1 in red, and we use the first cover is proved with the mappings and correspondence. This correspondence was mentioned before as a fundamental tool, and is proved this rectangle. The second cover in front of is commutative too, and was proved using this equality between the relations and composition of the corresponding relations. Finally, the other covers in the sides are proved by the conjectures and the theorem on homotopy category, even parts of its demonstration. I am referring to these covers, the lateral covers, and finally the diagram is commutative. This result was published in some paper in the year 22. Some application, we have the conjecture. Direction is time, translation is space in space-time. Direction is given by the curvature, and then the curvature is time. That is to say, we have a rate interpretation of the time. And translation is given by this collection of the states, and you can see this picture. The points of the manifold base are events in the space-time. This is event, the space-time. The points inside the Hamiltonian space. This is a Hamiltonian space. Are states of energy time. The manifold is this. The Hamiltonian space is this. Then the space is condition of the body moving through the space-time. In this part, we have the movement, and in this part, we have the some example in low dimensions of the what happened in the Fukaya category, derivative category obtained. The time is condition of the event, which do that this happened in the energy time. The lines given in omega sub x, and the perception lines. These lines are the fibers The fiber bundle is the field configured action and is the form that we call. Thank you.